Hello, this is an answer to a question about chapter number 6 and number 7 on the review. Okay, here comes the answer to this one. It says here a test consists of 20 multiple choice questions, each with 4 possible answers, one of which is correct. To pass the test, a student must get 70% or better on the test. If a student randomly guesses, what is the probability that the student will pass the test? So our first step is going to be to get our information. Our n is equal to 20, okay? Then our p is going to be equal to, now if you have 4 possible answers and one of them is correct, then 1 divided by 4, which is 0.25. Okay, so there's our p. And then our x is going to be, now look at c. It says to pass the test, the student must get 70% or better on the test. That must mean that if you have 20 questions and then you multiply that by 0.70, okay, then that means that what you have to get in order to get a correct, to pass the test, it's going to be 20 times 0.70. It's going to be 14 questions. So you must get 14 or better on the test. So that means that your probability is going to be that x is going to be greater than or equal to. Okay, so we're going to go over here to the greater than or equal to sign. Okay, so it's going to be greater than or equal to 14. So that's going to be your problems. Okay, so now one way of doing it is through the calculator or the tables. Now the problem with the tables in your book is that they don't go all the way up to 20. It goes up to 8 only. So basically what we have to do is make our own table. So what we're going to do is we're going to say, okay, x, and then here we're going to have p of x. So p of x. Okay, so now here we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And here we're going to use our function here to find our binomial distribution function. So it's going to be f of x. You go over to statistical, okay, and you look for binom dist. Okay, so now you're going to get these right here. Now this is your variable. This is the number of trials, which in our case is 20. Then our probability is going to be 1 out of 4, so it's 0.25. Okay, and then this is going to be false. Okay, so now we have our probability here. Now to fill it, the other ones, we go ahead and fill like this, and we get all of our probabilities. Now notice that you have these funny looking numbers here, and that's basically 0.00002575. So in order to avoid that, we can go ahead and make them into 4 decimal places. So we're going to go over here and we're going to format the cell, okay, and we're going to use numbers, and we're going to do 4 decimal places. Okay, so we're going to click OK. We're going to get that this is going to be our probabilities right here. Now notice that we want 70%, which is 14 or more. So what we would have to do is sum, okay, we would sum from 14 on down, and we press enter and we get that our answer is 0. So from 14 on down it's going to be 0. Okay, so the probability that that happens is going to be 0. Now our next way to do it is this. Now what we could do is find this probability and subtract it from 1. So what we're going to do is this. We're going to go to second in vars. We're going to go to binomial CDF. We're going to put in 20, comma, 0.25, comma, and then we're going to have all the way to 13. Okay, so that's going to be what we want. Now we're going to go 1 minus that answer, okay, and equal to that. So that's going to be, when you think about this, that's going to be point 1, 2, 3, 4. Then it's going to be 295, which is going to translate to 0 if we round it to 4 decimal places. So therefore, that's where this right here comes from. Okay, that's your answer right there. Now, like I said, the other way of doing it is through the calculator. Well, we did it through the calculator, which was this. Now, the other way of doing it is through StatCrunch. Through StatCrunch, you would go to Stat, we go out to Calculators, and we go to Binomial. Okay? Now, what we do is we say, well, our n is 20. We put 20. Then our p is going to be 0.25, 1/4. And then we're going to have greater than 14. Okay? So greater than 14. And we hit compute. And we get our answer, 0.00002951. And that's the way that we do number 6. Let's look at number 7. Okay, so number 7 is a little bit easier. All you have is your probabilities, the mean of any binomial distribution is going to be equal to, so the mean is equal to n times p. N times p. Okay? Which means that's going to be equal to 30 times 0.25. Okay? Which gives you, when you do that, 30 times 0.25 is going to give you 7.5. Okay? Then, to find the standard deviation, what you're going to do, to find the standard deviation, that's going to be equal to a square root. So we're going to go ahead and do this one because that'll be easier. We're going to go ahead and take the square root of n times p times q, where q is equal to q is equal to 1 minus 0.25. Okay, so now we're going to go back over here and we're going to say, okay, so let's look at the square root again. Okay, and what's going to be, it's going to be 30 times 0.25 times 0.75. Okay, which is going to equal to, when you do that, the square root of 30 times 0.25 times 0.75 is going to be equal to 2.37. So that's going to be equal to 2.37. That's going to be our answer for number 7. And those are the answers. Thank you.